Hello, everyone, and welcome to GitHub Universe 2022. I'm excited to join you here today with my teammate, Gwyn. We're going to talk to you about GitHub as code, managing all the GitHub things at scale. And first, a little bit of motivation. Why is this an interesting topic? Well, I think all of us have experienced trying to manage all the GitHub things, users, labels, milestones. We love our actions in all of our repos. And it turns out that managing these at scale can introduce some complexities, especially large organizations, large teams. You go from a handful of repositories to maybe hundreds of them. The manual management of those through point and click and copy and paste of scripts starts to break down at scale. That leads to a lot of this manual toil of trying to manage these things by hand. And it turns out we're developers. We like code. And so what we're going to see in this talk is actually applying code to help solve some of these problems at scale. And not only solve the problems, but unlock a ton of new potential. I think, using code, using the full flexibility of the GitHub platform, we can really get the most out of GitHub by applying a lot of the techniques that we're going to talk about in this presentation and enable advanced tooling and automation so that you can customize GitHub and get the most out of it. And when I say all the things, I mean all of the things, from repositories to the contents of those repositories, whether those are contributing MD files or actions, all the projects. We love project management on GitHub, some of the new capabilities that have shipped over the last few years, package management, teams, people, you name it. We're going to show you how to automate it throughout this talk. I'm sure everybody in the audience has experienced this, pointing and clicking, things get out of date, copying a GitHub action from one repo to another. It can get a little bit tedious. And it turns out this is actually a sort of familiar problem. It may not be immediately obvious, but we face similar challenges in a different domain, in the cloud. This is a screenshot of the Azure portal, similar thing if you're using AWS or Google Cloud. The idea here is we're building sophisticated cloud architectures. And what's the easiest way to get started? Well, it's to log into the Azure console, point and click a little bit, spin up a virtual machine or a serverless app or a container-based application. Sooner rather than later, we end up with these complicated architectures like we see on the right-hand side of this screenshot here, where it's really hard to keep it in your head how all these things relate. And furthermore, when it comes to repeating it, maybe we need to go from staging to having production, maybe having 2 production environments or more. And what happens when something fails? If we have to recreate this, we have to go back through that same manual process. Sounds very familiar. With GitHub, what happens if we accidentally delete some of the milestones or labels? How do we recreate that? And we'll see later on that it turns out recovering from that is really easy if you take some of the approaches that we talk about in this presentation. And so that's really where infrastructure as code comes in. Infrastructure as code is a way to declare your infrastructure using code. As it kind of sounds like, there are different solutions, and we'll talk through some of the trade-offs there. Some of the, sometimes the code is YAML or JSON or domain-specific language. In this talk, we're going to be seeing, declaring infrastructure in Go. But the idea here is you start from code and declare your whole infrastructure topology in code. Again, this is in the domain of cloud infrastructure, but we'll see shortly how the same techniques can apply to managing GitHub as well. Once we've declared that in code, we can automate the whole lifecycle. Instead of manually going and creating these things, the whole create, read, update, and delete part of the infrastructure lifecycle is repeatable. It's easy to scale up to many environments, and no more copy and paste, no more point and click. We can really use effectively software engineering to manage our infrastructure. Applies to the whole software engineering lifecycle, all the way from versioning infrastructure as code in source control. So we can version it in Git. We can do pull requests and code reviews. We can do Git-centric workflows. In fact, it's very common these days for infrastructure as code to be deployed triggered off of a Git commit. So maybe we open a pull request, review the changes to the infrastructure, we merge it, and then from there, the automation goes typically via GitHub Actions or some other CI/CD integration will go and actually perform those infrastructure changes. There's a lot of backstory leading up to how this applies to GitHub, but it will all make sense in just a couple slides. PS, we often abbreviate this as IaC. Infrastructure as code is a mouthful. It's a lot of letters, but just in case it sneaks into any of the subsequent slides, I wanted to call that out. The infrastructure as code landscape is quite rich and wide and deep, and it's been around for a while, dating back, 15 or so years ago from CF Engine, Puppet, Chef. You've probably heard of these technologies, even if you haven't use them. Ansible, SaltStack, these first category of infrastructure as code tools, I'll call them configuration-based tools, were really born in the era of virtual machines to help us manage the installation of software on those virtual machines. With the introduction of the cloud, we kind of moved into a different era of infrastructure as code, something we call provisioning. Instead of focusing on how to configure a virtual machine after provisioning it, we're actually focusing on the provisioning itself. And this really ties in nicely with things like serverless and containers and Kubernetes. I'm sure many folks have heard of these technologies or are even using them in your jobs today to scale on the modern cloud. And really the introduction of AWS and Azure and Google Cloud really gave way to this new era of infrastructure as code tools. I'll say Terraform is definitely a very popular tool in this space. Every cloud also has their own. So AWS has CloudFormation, Microsoft has Azure Resource Manager templates, ARM templates, and recently introduced a new language called Bicep. And that's sort of in the domain-specific realm, where you're using a custom-built language that's tailored to infrastructure as code specifically, which can become limiting, and the current era of cloud architectures tend to be much more complicated. And that's where the company Gwen and I work at Pulumi, we founded to solve some of these problems at scale, to really bring your favorite language, JavaScript, TypeScript, Go, Python, C#, you name it, you can probably use it with Pulumi. And since then, the Amazon Cloud Development Kit, CDK, has taken a page from that approach as well. And so that's what we're going to be using today. We're a little biased that we'll pick Pulumi, but most of the techniques you'll see today would apply just as well if you were using Terraform or one of these other cloud-specific technologies. And so what does it look like? Well, it just looks like code. So you'll see here, we're actually just creating objects. We can use for loops. It's a familiar language. So in this case, TypeScript, we're saying, hey, give me a new Azure Resource Manager group and then provision some things inside of that. And you can pick any of these languages. They have full fidelity. The great thing about this is developers, we love code. And so by using these languages, it really makes infrastructure as code and all the GitHub as code things that we're going to see in this talk much more accessible to a broader audience of developers. And there's a bonus here, which is when GitHub Copilot came out, we said, hey, Pulumi is just using code. I wonder if Copilot would work. And it turns out, yes, Copilot will happily write your infrastructure as code just as well as it would your application code. So I encourage folks to give it a try. It's really fun to see in action. To summarize on the infrastructure as code part of this and move on to GitHub as code, the workflow roughly is declare infrastructure in code, deploy that infrastructure either manually at the command line or, as we'll see later, through more sophisticated integrations like GitHub Actions, version that code. So this is not just for the initial provisioning, but also the continued evolution of that infrastructure. So if I need to, scale up my infrastructure, augment it, add things to it, fix bugs in it, infrastructure as code tools like Pulumi know how to take those changes and incrementally move them forward and roll them out with minimal disruption and minimal downtime. And then finally, as we're doing these updates, of course, we're using code. So if we want to see the full history of changes to our infrastructure, we can just go to Git, take a look at the change log. We can go to GitHub and look at the pull request history to see who approved these changes. It's a really rich way of visualizing infrastructure, just like we do all of our code changes. So here's where the twist comes in. Infrastructure as code is not just for clouds, as you might imagine. Of course, AWS, Azure, Google Cloud, even Kubernetes, Helm, VMware. It would not be surprising to think of using infrastructure as code for these technologies. In fact, it's pretty much table stakes these days that you would use infrastructure as code for those cloud providers. But it also works for software as a service providers because it turns out, a repo or a team defining GitHub or a PagerDuty escalation list. These are all pieces of infrastructure that need to be managed as well. And Pulumi and many of those other infrastructure as code tools support a wide array of providers, including SaaS providers. And so you can see some of them here, Auth0, MongoDB. A lot of times we're wanting to apply these infrastructure as code tactics to these other providers as well. And that's what leads us to GitHub as code. What is GitHub as code? Well, it's all the same things we saw for declaring cloud resources. It's just declaring GitHub resources in code and eliminating the point and click as a result. We can automate the entire lifecycle, the create, read, update, delete of all of our GitHub resources and really scale up to many organizations and repositories to go from a handful all the way to hundreds without losing our minds and really being able to apply software engineering techniques to keep that complexity under control. And then really use the code practices for GitHub things. And so we can actually use GitHub to version changes to GitHub, which is pretty wild to see, a little bit of inception there. In fact, to jump in and see this in action, I'd love to invite Gwyn on stage to walk through GitHub as code, starting with infrastructure as code, and then I'll see you back in just a moment.
All right. Thanks, Joe. So what you're seeing on my screen on the right is a little GitHub org called Shiny Platypus. And it's got some settings, it's got some repos and some teams in it. And what you see on the left is a program that is going to create a new team on the Shiny Platypus org. So what I'm going to do here is I'm going to use the Pulumi CLI to bring up a new GitHub team, and it's going to be called Universe because that's where we are. So the way I do this is I run Pulumi up on my terminal, and it's going to show me a little bit of a preview and showing me what infrastructure I'm going to create. And it's saying it's going to create a GitHub team, and it's asking me for confirmation if I'm okay with that change. And yes, I am. Let's see what happens. So this should be pretty quick, but I'm going to refresh on my right side and notice that I have a fabulous new team. Welcome to the universe. That's super exciting. But wait, there's a sad little button there that says add members. So a team should have members and other things so that it can operate as a team. Fortunately, I can just uncomment some code here and go ahead and create a team membership for Joe. And Joe is right here, so I think it would make sense to put him on this team. And so that I give Joe something to do, since he's here, I'm going to create a repository as well. With my code, what I do here is I'm going to initiate a repository, and I'm going to call it, actually, I'm going to give it a more fun name than Hello Universe. And we can see that pop up later on my org. I'm going to set the default branch to be main, as is customary. And then I'm going to give some permissions to the team that I just created using my code. And notice that I'm not actually referencing this team by name. I'm just going to go ahead and reference the team that I first created right here. And Pulumi knows that this team has an ID on GitHub, and it's going to pull that and use it to create permissions for this team on the repository that I'm creating. Let me go ahead and do the export and error handling as well, and then see what happens when we provision this infrastructure with the CLI. This time, I'm just confidently going to pass the yes flag to my Pulumi up. I see the preview. We're going to get a repo, a new team member, and some permissions for this team. So let's refresh here. Oh, look! Yay! Joe is now a member of the Universe team. And if I go to that team's page, I can see that it has repositories. And, well, it has one repository, and it is the repository I just created. And the Universe team has admin rights on this repository. So that's pretty cool. But these are just some basic GitHub objects that you can create using this infrastructure as code concept. Let's think a little bit further. And we are all on GitHub because we love open source, right? And the only way to make open source work really is to have members, to have community members. And our community members need to be able to collaborate with us. And one of the things that we do when we collaborate is we tell people how to collaborate. So in my org, I have a few repositories. I have some example repositories: development, production, and staging. And if I go to this repo, I see that sadly it does not include instructions on how to contribute. And Most of my repos have this problem. So what I'm going to do is go back to my Pulumi program, and I'm going to open some PRs, some pull requests. I know that the repos that I want, I'm passing them in here by name, but if my organization has more repositories in it, I might keep them in a file somewhere and read them in. Again, because we're writing code, this is really just up to you. For the purposes here, I have a little function where I abstracted away what it takes to create a pull request. We're going to create a branch, and we're going to pass in a contributing file onto that branch, create it on that branch, and then we're going to open a pull request against our repos. And we can do so just with code with a regular for loop. So let's go ahead and run Pulumi up again. So this one will take a little bit longer. Let me go back to my repositories. You can see here that there aren't any pull requests open on staging, development, or production. But you can see on my left that Pulumi is busy creating these things for us. Let me refresh because I'm super impatient. All right, one more refresh. Ha! There we go. I'm always so excited when this actually happens. It's really cool to see this just show up. And I'm going to click on this pull request for production, and look at that. I have an open pull request that says add a contributor's guide, and it adds a file, and we even have a few. Here we go. Remember, every repository should have a contributor's guide. As you've just seen, we can use code to automate so many of the things that we have available on GitHub. We can create teams. We can create repositories if we want to. I don't know what your GitHub community looks like, and the details are really up to you. And because you can use code to provision all these things, the details are really, truly up to you. We have all of the examples in the Pulumi GitHub provider library for you, so you can really just explore, and the sky is your limit. So what does this look like in practice? I already gave you a little bit of a taste of what it looks like when you have an organization that is missing critical files. My example was a contributing file because I love open source, but you might as well need to add workflow files to all of your repositories or important security updates. And you can use infrastructure as code to manage all of that centrally. And you will have it all in one place. You know what the state looks like. And there's just going to be less scrambling around in a UI to find what you need. But of course, there's more. So Joe made these slides. And this picture is absolutely a real picture of what I look like when I just broke production. So thanks, Joe. But I just showed you what the Pulumi CLI looks like, and that still requires a human operator. Someone still has to go and manually create the updates and make the changes, even though it's centralized, and then run Pulumi up and see what changes. So we have a solution for that. I just had a code repo. I just wrote some code. I can keep that code on GitHub. And then I can use a couple of GitHub-friendly tools to make sure that my Pulumi code stays updated, public, changeable by all the members of my community via pull request or suggestions or issues. And then I can use GitHub Actions to wrangle my Pulumi state and make sure that everyone can use it at the same time, which brings us to my next demo. All right, so I'm back on GitHub this time. So what I wanted to talk a little bit more about is the abstraction that goes into managing your online GitHub community. So what I have here is my demo repository called Demo Universe, because I'm very creative. I have some teams set up on my Shiny Platypus org. Let me show you those first. We have teams. Notice the universe team that I created earlier, but we also have a team called animals. And this team has a few sub-teams. One of them is called platypuses, and the other one is called unicorns. This is going to be important in just a minute, I promise. And basically what I'm doing here is I'm reflecting the structure of an organization that may own different repositories or may report to different people if you're, a serious company. So this is just the way that GitHub has to reflect hierarchical structure and organization of your teams, for example. And back to my demo universe repository, we have my favorite of all databases, a YAML file to capture the team structure. So you can see here that my org is Shiny Platypus, and my top level team is called Animals, and it has some sub-teams. You already know the names because you just saw them in the UI. And then I tweaked my Pulumi code just a little bit to reflect the structure using Go structs and some abstractions, reading YAML files in, and setting up the teams. This code is going to be public, and you can look it up later, so I'm not going to spend too much time here. But what I want to show you is that this is going to create a few more abstractions. For example, in this other YAML file, I'm showing how we can, show ownership for repositories and create these relationships. What this means is that if I am a new community member or a manager of the Shiny Platypus organization, I can go here into this repository. I can go into the teams file and I can say, hey, so Susan and Thomas have been working really hard to be a member of the Platypus team, so I want to move them. And I want to give them access to the Platypus team's repository permissions and settings. So what I'm going to do is I can literally edit these files and adding them. And I'm going to go ahead and update add Susan and Thomas to platypuses. And I'm going to open a pull request because I want to show you two things. So the first thing I want to show is that I have a GitHub action set up that triggers on a pull request. What this does, it runs a Pulumi preview, which shows me, hey, these are the GitHub objects I want to create as part of CI workflow. And more than that, and this is going to take a minute, it's going to show on my pull request whether my changes are acceptable and also what they are. So this is going to take a little bit of a minute. Here we are. Let me go back to my pull request and see what it says. Just a little bit longer. And here we go. Our Pulumi preview action actually shows us what GitHub things we're creating or we're going to create by making these changes to our organizational repository. So here it says it's going to create a team membership on the Platypuses team for both Thomas and Susan. And I'm just going to go ahead and hit merge. And you guessed it, I have a workflow set up that runs Pulumi up on a merge to main. What this means, I can go back to my team structure and see what happens to my Platypuses team as soon as this workflow finishes running. And here we go. We have merged a pull request, and let me go back to this page and see if we can welcome new team members to the Platypuses team. Yay! We have more help on our team now, and we didn't have to go through anywhere to find out whom to add. We could just go and add them in one place. Then GitHub Actions takes care of the rest. And now I'll hand it back to Joe to finish us out.
Wow, thanks, Gwen. Those were some amazing demos, and I think really drove home the point about being able to use software engineering to manage all of the GitHub things. I love seeing Go structs and some abstraction helping to build more reusable and repeatable patterns. And I think just to wrap things up, I wanted to do a quick recap of what we saw today. We saw a quick overview of infrastructure as code and the history of infrastructure as code, how that applies to cloud infrastructure, why that really helps you to automate away a lot of the manual point and click, copy and paste, and frankly, toil. We then saw how those same techniques could be applied to GitHub, something we called GitHub as code during this talk, but really is no different than the basic infrastructure as code that a tool like Pulumi offers. It's just that the SaaS providers like GitHub and others offer REST APIs and programmable surface areas so we can really access them through infrastructure as code very easily. We saw that we can use automation to scale more easily, to go from a handful of repos to hundreds of them and well beyond. I love Gwen's focus on building out the community and the best practices so that we can make sure that all of our repositories and our entire organization are open and friendly to the community. We then saw a bit of inception. We saw how to automate GitHub using GitHub itself. It turns out Pulumi really works great with GitHub Actions, and that you saw that Git-oriented workflow where we can just open a pull request, see what those changes are going to look like before we make them, click the merge button, and then everything just magically happens without having to run a CLI manually and still get all of the benefits of infrastructure as code and automation at scale. And with that, I'd love to thank you for joining Gwen and I here at GitHub Universe. As Gwen mentioned, all the code's available open source. We've put together a blog post here that goes through some more in-depth examples if you wanted to learn more about what you heard today. Thank you again.